So I'll first introduce you to the subject of mechanics. What mechanics is all about. What do we do in mechanics? See, in mechanics, particularly here I'll be studying with classical mechanics. Here I'll be dealing with classical mechanics. Right. See, mechanics is all about study of system of particles. Right. System of particles, study of system of particles, I call it mechanics. Right. Then here, in fact, if the system of particles has got large inertia, we call it classical mechanics. Right. So here I'll be studying two mechanics. One is classical mechanics and other is quantum mechanics. Here I'll be confining myself to a system of particles having large inertia, and here it will be a study of system of particles having small inertia. This is all about the world where we are living. This classical mechanics is the mechanics of the world where we live, right? And this is basically, you can say, subatomic world, like atomic system, molecular system, and then you can have nuclear system. They all are quantum systems, right? So it's a world of subatomic particles, right, where the inertia is very small. Inertia of the particle goes in the range of 10 to the power minus 27, where it is more than 10 to the power minus, say, 4 kg or so, right? This is our world. This is a world where we are living. This is the world of your atomic, subatomic world, where the inertia is very, very small. The inertia of particles are very small. All right. So right now I'll be confining myself to this part. Right. I'll be confining myself to the classical mechanics, where we are studying system of particles having large inertia. Now, it has got 3 steps. When you study any system of particles, first of all, you define the state of system. You define state of system. Then the second thing you do is you determine the state of system when you start studying it. Find the state of system at t equal to 0. When we start studying any system of particles, first of all we determine the state of a system, and then we determine how the state of system changes with time or vary with time when the system is subjected to the external forces, right? The external forces. How do you define the state of system? See, what actually you are interested in when you are studying system of particles. What actually you are studying? We are studying attributes, right? Actually, when you are studying system of particles, you are studying different properties, right? What do you study when you meet a person? Suppose you meet your friend, any person, right? What you are interested in when you meet any person? Say this is a person, right? So what you are interested in when you meet someone, right? You are interested in his properties. You are interested in what you study when you meet someone. Weight, obviously, height, these are characteristics of a person. And then, of course, complexity is one attribute. Then whichever system you are studying, whatever be the system, when you are studying any system of particles, system of human being or any person, then you are basically studying his attributes. The attributes can be weight, height, complexion, it can be gender, then it can be, say, thought, it can be IQ, it can be emotions. These are some of the characteristics of a person, right? We are interested in these attributes. We are interested in these attributes. There may be other attributes as well, like behavior, right? Like behavior. And then you can say his personality. What else? So there can be many. If somebody is English graduate in English, he may have a lot of word stock, so he can add many more things to it, right? We are people of physics. So these are some of the emotions, these are for some of the characteristics which I can recall. When you meet someone, you are interested in all this. You are trying to study all these attributes, right? But then here also, when you are studying system of particles, what you are interested in? You are interested in position, then you are interested in velocity of particles, you are interested in linear momentum, then you are interested in angular momentum, then you are interested in potential energy of the system, that is, you are interested in configuration, you are interested in motion, which is defined by kinetic energy. Basically, these all physical quantity which I have written over here are telling you about some or other attributes. Like position velocity is one of the attributes. Position velocity is the attribute. Linear momentum is all about motion. Angular momentum is all about motion. You can say angular motion. And it's all about potential energy, all about configuration. And K is again all about the magnitude of motion, right? So they are representing some kind of attributes. They are representing some other kind of attributes. So we are interested in these activities. We are interested in these. Be it classical or quantum mechanics, both are system of particles. So we are interested in these attributes, right? The attributes are not changing in classical and quantum. There may be some few more attributes in quantum mechanics which you may not find in classical mechanics, like say spin. You don't have in classical mechanics, right? You have a spin angular momentum over there. Here also you have a spin angular momentum, but the spin angular momentum in classical and quantum is different. Here it is spinning, whereas in quantum it's not spinning, right? So you may have some more attributes in your quantum mechanics which you may not find in classical mechanics, like say spinner-spinner interaction and all that, right? So similarly, when you meet a person you are interested in, you have these attributes. But then we are people of science, we are intelligent, right? So when I define the state of system, out of these I must choose the basic attribute. So it's always difficult to work with these number of physical quantity when you are studying a system. In fact, we have to look for some basic attributes, right? Out of which I think that these can be a basic attribute, right? Once we know position and velocity of all the particles, I can very well know what is the linear momentum, what is the angular momentum, what is the potential energy, what is kinetic energy, if I know the mass, right? So this can be the basic attribute. Get your point? This can be the basic attribute. Other attributes can be expressed in terms of these basic attributes. I can call it basic attributes. Similarly, when you read a person, weight can be a basic attribute, height can be a basic attribute, complexion can be a basic attribute, gender, thought can be a basic attribute, IQ, emotions can be a basic attribute. But then what is your behavior? See, behavior is a linear combination of, say, emotions, IQ, thought, even gender to some extent. So it's all linear combination. This is not a basic attribute, in fact. This is a linear combination. If you know these four attributes, you can predict the behavior also. So I don't regard behavior as basic attributes, right? Personality again is not a basic attribute. Personality is all about emotions, IQ, thought, gender, complexion, height, and not weight, maybe weight also. Your physical appearance depends on weight. So personality is a very complex attribute. It's not a basic attribute. This can be regarded as linear combination of all these attributes taken together. So I'll call these as basic attributes, right? We call this as basic attribute 1, 2, 3, 4, 5, 6, 7. Here I'll call these as basic attributes. So I'll define the system by these basic attributes or by these basic attributes. When I define any system, see, it's always better to study a system with with a simpler definition of state, right? And again, when you are studying a human system, a realistic system, a living system, then obviously the definition of state may vary from person to person. Like suppose if I consider a person who is studying human being, like say he or she is a kid, say 4 years old. My daughter is 2 years old. So if my daughter want to study any person, what she is going to see? She is just going to see the weight to some extent, height and complexion. Even she may not, or to some extent gender, right? So her definition will be confined to only these 4 attributes. Her definition of state will be confined to these 4 attributes only. She may not be interested in your thought, your IQ, your emotions. So her definition will be like this. As you grow, you gather lots of wisdom, and your definition about the state of human being becomes more and more holistic. Right? More and more holistic. As you grow with the age, say you'll be adding your definition of state will become more and more holistic. So, but this is not so over here. See, the application of physics to a non-living system is very precise, right? In living system, it's not so precise. It's not precise. The things cannot be precisely defined. But just I am trying to draw an analogy between the mechanics and the system of human being, right? So these are the basic attributes. So we define the state of system as respective position and velocities of all constituent particles forming classical system. Respective position and velocities of all constituent particles forming the classical system, right? Similarly, if I want to study the human being, then I will define the state by respective weight, height, complexion, gender, thought, emotions, and IQ of the human being, right? Of all the human being forming a system. If I have, say, classroom of 100 students, then if I have this definition of state, then the state of the classroom will be defined like this, right? So when you meet a person, you define the state. Your state has got more number of attributes, more number of basic attributes. Of course, your living system is a very complex system, right? So that's the definition of state. That's the definition of state. And it was defined, say, 500 years back, and still we agree to this definition. See, when you read mechanics, you don't change the definition of state quite often. This is the definition of state which was defined by great Galileo and Newton, and we are following that. There is no problem with this. There is no problem with this. So because these are really very basic attributes, because I can evaluate all of the physical quantity by once I have a good idea of the position and velocity of all constituent particles, right? Then once you define this as the state, say the 7 attributes as state of human being, then what do you do next? What's the next step? First step is to define the state of system. What's the next step? Next step will be to determine the state of system. At t equals 0, we must know where is the particle. What is the position velocity of the particle at t equals 0? We must determine the state at t equals 0. We must determine the state at the time when we have started studying. So we must determine the state at t equal to 0. If you want to study a person, you must determine the weight, height, complexion, gender, thought, emotion, and IQ at t equal to 0. The time instant at which you started studying a person. You must know all this, right? You might have seen some old person is meeting you, or you are going to your home to meet your grandfather, great-great-grandfather, or some old person who is genuinely interested in you. Then you will be finding that they ask lots of questions, right? Because they need to get the idea about thought, emotions, and IQ, right? By seeing you, they will get an idea of these things. But then, in order to get an idea of your thought, IQ, emotions, they must ask lots of questions in order to get a good idea of these attributes at t equal to 0. Good idea of these attributes at t equal to 0. Alright. So, once you start studying a system, you must first find out what is the position and velocity of the particle forming a system at t equal to 0. And the same thing the old person is doing with you. When the old person meets you, he is genuinely interested. He will be first determining these attributes. I don't regard this as the state, this is this part of definition. Only I have taken these 7 attributes as definition of the state. So when you meet anyone or someone meets you, someone try to study your mechanics, then he will be genuinely interested in knowing all these things at t equal to 0 when he has started studying a system. So for that he may ask lots of queries, lots of questions. What do you do? What do you do when you are leisure? What do you do when you are in school? How much time is spent in the library? How much time is spent watching movies, right? How much time is spent in moving into shopping mall, or how much time? So that's all about knowing your all these attributes. In fact, he is interested in all these attributes by asking many questions. He is all interested. What he want to do is he want to study these attributes, right? He want to get the idea of these attributes at t equal to 0, right? You want to get the idea of these attributes at t equal to 0. Similarly, when we are studying a system of particles, non-living particles, we must have a good idea of what is the position and velocity of all the particles forming a system at t equal to 0, right? Then what's the next step? That's all about what we call this process, determine the state of system forming a system, determine the state of system at t equal to 0. This is called this thing, this determining the state of system at t equal to 0 is called statics. See, statics is not static. It's nothing to do with rest. Statics is all about determining the state of a system at t equal to 0. Determining all these attributes of a person at t equal to 0 is all about statics. The old person is right now studying statics. I am right now, when I find his position and velocity, what I am doing is I am studying what statics. I am determining the state of system at t equal to 0. Right? Now, what's the next thing I should do? I must read now this one. Once I exactly know the state of system, then I must determine how the state of system is varying with time when system is subjected to external forces. If particular system is subjected to an external force, how the velocity and position is changing, how the state of system is changing. So I must analyze the forces now. What are different forces acting on the system? So I must analyze the force and then get to know how the force is going to affect, or how the force is going to vary the state of system with respect to time. Getting a point? The old person who is right now interested in your statics, once you know the statics of your, once you know your statics, once you determine what kind of thought you have, what kind of IQ you have, how much emotional you are, then his type of question, right now he was asking question about you, keeping you at the center, right? Now his type of question will change. Now what he will be asking is different. He will be asking some different set of questions. Those questions are basically all about your environment, what your fathers are doing, what your mother is doing, how much qualified your father is, where do you live, in which colony, where do you study, who are your friends. He'll be more interested in your surrounding now. Do you know what exactly he want to do? He is interested in the forces to which you are subjected to. He is basically interested in what kind of forces you are subjected to. Just like I am interested here in this force like mg, normal reaction and all that. So I am interested in what forces this particle of mass is subjected to. Similarly, the person, the older person who is interested in you, since he has studied the statics now, he has determined the state at t equal to 0. Now his set of questions will be different. Now he is interested in what kind of forces you are subjected to. And that's why he is asking question about what is your school, where is your home, who are you, what your fathers are doing, what your parents are doing, how much qualified they are, right? All sorts of questions. It's all about environment, right? It's all about environment. Who are your friends, right? That's all about environment. He is studying the environment so that he can get a good idea of what force you are subjected to. What are the forces you are subjected to? Why he need to know the forces? Only then he can get an idea of how the state of system is changing. How the state of system is changing, only then he can get a good idea, right? So right now we are interested in forces, and once I know forces, what will I do? Then here I can apply Newton's second law. Once I know the forces, I can get an acceleration. What is acceleration? Acceleration is a physical quantity which characterizes how the state of system is changing. Acceleration is a physical quantity which tells you about how the state is changing. Once the old person get a good idea about the force you are subjected to, now he will make a prediction. What he will say? He will say, this young person is going to do very well in his life. This young person is going to become a great physicist. Do you know what he is doing now? He is now reading your dynamics. He is telling you how your state is going to change with time, what you will become in future. See, as you grow with the age, you become pretty good at dynamics. This is all called dynamics. This is something called dynamics. Determining how the state of system change with time is all about what we call dynamics. For that, we must get a good idea about the forces the particle is subjected to. We must get good idea about the forces a particular human being is subjected to. Once I have a clear idea of to what force, to what push and pulls, to what kind of society, to what environments the person is subjected to, we can pretty well know that what the particular person is going to become in life, right? So he, the old person who has studied all your forces, now he will use experiences. See, the dynamical equation of motion in case of non-living particles can be written very easily in this kind of equations, but we don't have a well-defined dynamical equation for the human being. We have to use our experiences. We have our own way of studying dynamics based on our experience. That's all about dynamics. That's all about dynamics. So dynamical equation of motion in real life cannot be written in terms of equation. You have to use experiences of your life to get the dynamics of a human being, right? To get the dynamics of a human being, you must use your experiences. There is no clear-cut formula for this. So sometimes, they will tell you about your future. They will tell that this young person, this particular kid is going to become very good, very great scientist or very great person in his life. Sometimes he might also say that this child is not going to become very good. He will defame the parents, right? And sometimes you also see that old person is giving some advice to your parents that you send this student to a very good school. Do you know what exactly he is trying to do? He is trying to he is trying to change your environment so that you become a good person, because ultimately your dynamics depends on the external forces. So they will tell you, suppose I come to know that this young person is very good, he has a very good thought, he has a good IQ, then I'll just suggest the parents of that young person so that I'll tell them that you send him to good school so that your IQ develops very well. So he will give some advices so that the force, external forces can be changed, and so that the person grow into a very good person, right? So that's how the mechanics works. That's how the mechanics works. So we can apply the dynamics or mechanics qualitatively to living being also, right? Living system also. So that's how you study the mechanics. So first step is you determine the state of system. First you define the state of system, then you determine the state of system at t equal to 0, and then you study dynamics. Dynamics is all about how the state of system is going to vary with time if system is subject to external forces. There we will study how the respective position and velocity of the particle forming a system will vary with time, how thought, IQ, emotions, and these all things are going to vary with time when the particular person is subjected to such and such environment, such and such forces, so that I can just able to say what will happen in future to this person, right? I'll give you a historical example. See, when our first Prime Minister Jawaharlal Nehru met our former Prime Minister Atal Bihari Vajpayee for the first time in first Parliament in 1952, he just studied, Nehruji studied the person Atal Bihari Vajpayee, the great Atal Bihari Vajpayee, and at that time itself he predicted that this young person is going to become leader of the nation. You know, Nehru was very good at dynamics. He predicted at that time, and finally after say for 45 years the thing came out to be true. He became the Prime Minister 3 times, right? So sometimes people have very good dynamics, they apply, they are very good at studying dynamics. And remember one thing, when you are very good at the dynamics, see, the first and foremost thing for studying dynamics well is that you must know the statics well. If you don't know the statics, you can't predict what will be the state of system at a later time t. For that, you must know exactly what is the state of system at t equal to 0, right? Must exactly know what is the state of system at t equal to 0. So to have a good dynamics, you must have a good statics, right? You must know statics well. You must know the state of the system at t equal to 0 well. Then only you can say about future state of the system, right? So that's how we study mechanics. There are the 3 steps, and mechanics is all about these 3 only. These 3 steps only. So actually this is something historic. We have defined state of system for the first time, and that is well settled fact, and now we are really concentrating on these 2 only, and more importantly dynamics part. Now apart from this, we have 3 laws. They are called Newton's laws. I'll discuss something about Newton's laws. What are Newton's laws? Tell me. See, one thing is very surprising to it may look very surprising to you that we are reading Newton's laws. We studied for the first time at which level? Say 7th standard, or if not 9th standard, you must have read at 9th standard, and then you have read about Newton's law 11th standard, and then you have read Newton's law in the first year of graduation. Then you will read it in first year of masters, and then when you do PhD, then also you study Newton's laws. So what's so special in this Newton's law that we have studied at all this standard? How Newton's law become different at these standards? Say, Newton's laws does not become different. Our understanding of the Newton's law improves at all these levels. So you have 3 laws. In fact, they are laws of nature. They are basic law of nature. So what is first law? Can you tell me about the first law? What is the first law of Newton, or first law of nature? How should you define? You might say that a body at rest or in motion has a tendency to be at rest or be in motion, or you can say a body which is in equilibrium will tend to remain in equilibrium, has got a tendency to remain in equilibrium unless you apply an external unbalanced force, right? I'll say this something in a broader way. I'll say every natural system has inherent tendency, I'll say, every natural system has got inherent tendency to maintain, you can say maintain its state are called equilibrium state, you can say. Every natural system has inherent tendency to maintain its state unless it is subjected to an external influence. Unless it is subjected to an external influence. Get your point? Every natural system has inherent tendency to maintain its state unless it is subjected to an external influence. How many of you wake up happily in the morning? How many of you wake up happily in the morning? How many have a desire to wake up early at 6 o'clock? Can you tell me? Do you want to wake up at 6 o'clock? Every day I set my clock in my mobile at 5:45. But it's recorded where I have seldom, very often, I never wake up. I never wake up at 5:45. I usually wake up at 7. Because see, we are all a natural system. We have the tendency to maintain our state. If we are sleeping, we want to sleep. We want to sleep. Because that's the lowest energy state. We want to maintain it. We want to maintain it. If we are sitting, it looks as if we keep on sitting. Even if we are thirsty, we tell someone to bring water. If it is possible. If it is actually possible. Right, so we have a natural tendency, we have an inherent tendency to maintain our state. We have inherent tendency to maintain our state unless we are subjected to some external influence. Right? If somebody wake up. Or suppose I have the exam at 8 o'clock. That's a big external influence. I will wake up at 6. Because now I will be subjected to an external influence. If suddenly some earthquake come, I will wake up at 6 o'clock, right? Because I have to run out. So, unless we are subjected to some external influence, we have the inherent tendency to maintain our state. That tendency is called, you call it inertia. We have inherent inertial tendency. Every person has got inherent tendency. We have inherent tendency of maintaining our state. We have inherent tendency of maintaining our state. Sometimes that's good also. If suppose I am the topper of my classroom, if I am the topper of my classroom, I would like to remain topper. Sometimes this inertial tendency does help us. Right? See, I am trying to quote examples from real life, but then there can be certain discrepancies also. Right? If somebody is at the bottom, he is having the lowest rank in the classroom, he might tend to improve it also. He might want to improve it, but he might like that he don't do hard work and then his marks improve. So he'll be having inertia in doing work. He'll have inertia against doing work, right? So we have the inertial tendency. Everybody has got inertial tendency. If I keep, say, a body of mass m over here, this body of mass m will remain at rest even if I come 10 years after and I see this body. It will remain at rest. Now this body has got inertial tendency. This body has got inertia. This body has got tendency to remain in the same state. So if I come after 10 years, I will see the body at the same position and velocity 0, be at rest. If suppose I have a body which is moving 10 meters per second as a frictionless surface. Regardless of after what time I see, then I'll see that this body is still moving 10 meters per second, provided don't have an external force over here. Don't have any external force over here. So every natural system, be it a living system or a non-living system, has got inertial tendency, inherent tendency to maintain its state, Everybody wants to remain in the same state. We have the inertial tendency. If some exam is announced, how do you receive, what's the reaction? If I say we have the exam 1 week after of mechanics, how do you react? The first reaction is something like, why this exam is being held? You will oppose it. Why? Because you have been living a lifestyle. You wake up at 8, then go to your school, and then you have your own state, you have your own routine life, right? And when I announce the exam 1 week after, your state tends to change and you oppose it. You have a tendency to maintain your state. You read for 4 hours, right? And when exam is announced, you have to now read for 6 hours. So you have tendency to oppose that. You have inherent tendency to maintain your state. So you receive the news not with joy. You don't feel happy that after 1 week you have your exam. Because now you have to change your state. You have to read for now 6 hours. So you oppose it, tend to oppose. You just say postpone the exam, let the exam be held after 1 month, so that you can maintain your state for a longer duration of time. So you have tendency to maintain your state. You have a tendency to maintain your state. That's why we do not like the examination. They tend to change our state. When we wake up at 8 o'clock, I have to wake up at 6 o'clock. Right? So I oppose it because I have a tendency to maintain my state. Right? We don't want disturbance. Right? We want to maintain our state. We are enjoying our life. We want to enjoy. So what was second law? This was all about first law. This is all about first law. What is second law? Second law, see, the first law which we read was every system has got inherent tendency to maintain its state, right, unless it is acted upon by an external influence. Now, it means if some external influence is acting on you, then your state should change. Does it mean that? From the first law, I get an idea that every system has got tendency to change its state unless every system has tendency to oppose any change in state or maintain its state. Same thing. Every natural system has tendency to maintain its state or to oppose the change in state unless it is acted upon by an external influence. It means that if I subject the system to an external force, say F, then it means the state of system should change. It remains at rest or it has the same state till no external force is acting on it. Right? Till no external force is acting on it. I wake up at 8 o'clock till I don't have any urgent work. So I will every day wake up at 8 o'clock. But if I have to catch a train at 8:30, will I wake up at 8? I have to prepare for that. So I'll wake up at 6 o'clock. Right? I have to wake up at 6 o'clock. If somebody tells me that you have to teach psychology, I don't know it. I have to wake up at 4 o'clock, study that psychology and then teach. So that's a great pressure, that's a great influence on me. That teaching a psychology tomorrow will put so much of influence, even I won't sleep. I read psychology for the whole night and then I have to teach it, right? So this usually happens when you are teaching for the first time or you are a new teacher. When you are a new teacher, some of you may become, then you have to read it. You will wake up in the morning so that you prepare your lecture well, right? So if there is some external influence, the state will change. The state will change. That's something which we are getting from the first law also. If some external influence is acting on you, the state should change. But then, second law talks more about it. Second law not only stops at saying just by saying that if the external force is acting on you, then the state of the system will change. It goes beyond that also. It also talks about the rate at which the state will change. It also talks about the rate at which the state will change. It says the change in state or the rate of change of state depends on strength of influence. Right? Strength of influence. If tomorrow I have exam at 9 o'clock of say mechanics, I'll wake up at 6 so that I can study for 3 hours and go to exam. Right? So I announce you that you have exam at 9 o'clock. Those who are waking at 8 o'clock will wake up at 6 o'clock. And if suppose I don't announce exam, if a college announces this exam, some of you may wake up at 4 o'clock only, because the influence of your college test will be higher than my test. You can't miss my test, right? You can afford to perform not so well in my test, but then if your college announce this exam will be recorded in your career. This exam will be there on the paper. This exam will be there on your degree. So your college exam will have huge influence on you, and will wake up at 4 o'clock. In my exam, you will wake up at 6 o'clock. In your college exam, you will wake up at 4 o'clock. If you are going for some competitive exam, you may wake up at 3 o'clock also. So how much your state will change? A person who has the habit of waking at 8 o'clock, how much early he will wake up will depend on who is announcing the exam. If one of your friend says, you give my exam, he announces the exam, you won't be so careful. But then it depends on who is announcing. If your college announces exam and that is going to be recorded, the strength of influence is higher, right? So it all depends. Strength of influence is higher, the rate of change will be high. In your college, you have say 6 periods. 6 hours, 6 teachers teaching you. Are you equally serious in all the periods? Is it? Are you equally serious in all the 6 periods? Do you enjoy all the 6 periods? Certainly not. Those who are teaching well, you are more attentive. You can't afford to miss their class. If it is a mechanics class, you can't afford it. If it is optics, you can. Looks easier for you. So the strength of influence is different. If it is mechanics, if it is electromagnetic theory, or it is quantum mechanics, they are very, very important subject. You can't afford to miss those lectures. Or it may depend on a person also. There may be a person A who teach well. There may be a person B who is not audible. So in that case, you'll be more attentive in listening to A than B who is not teaching well, or if he is teaching well, he is not audible to you. So then you'll be more attentive in the person who is giving a good lecture. If B is not teaching well, you won't be very much interested in B. So the state you may like to sit at the back. Say if B is not teaching well, you may sit at the back, read some magazine or so, right? Or do some message or to play some games, right? So then again, it depends on what is the strength of influence. Some people have got huge influence. They hypnotize you, in fact, right? Some people really have a huge influence, and your state becomes very attentive. Your state changes to a very high extent, whereas some people are not having very influential. They may be very good, not very knowledgeable, but then they may not be so much influential. They may not exert a so strong influence. So in that case, your state, you may not be very serious, you may not look very attentive. So it depends on the strength of influence. It depends on the strength of influence, right? And what else it depends? If influence becomes stronger, the change of state will be high. The change of state will be stronger. Rate of change of state will increase, right? State will change at higher rate. What else it depends? What else it depends on? It also depends on you. It also depends on your inertia, and in fact inverse of inertia. So if I call it cause, it depends on, I'll call it effect. If I call it effect, effect will depend on strength of influence, that is the cause of change of state, and it has inverse dependent on inertia. See, when I teach a classroom, the classroom consisting of say 50 students, then I teach same thing to all 50 students, but some of you may understand better. Some of the students understand better, some students understand less, assuming they have the same background. All are 80% plus 2. So why do some students understand better? Why some students understand less? So it all depends on inertia. Some students, they are very receptive. They have low inertia. They are very receptive. They take everything on the face value. Don't neglect anything. They listen very carefully. The inertia is less. So the change in state is higher. The change in knowledge state is higher. Whereas some student, they might feel that I know much of the thing which is taught to us. In that case, he may not understand better. Right? So he has got huge inertia. I teach mechanics, say, to 12th class student. Right? I teach mechanics to, say, a graduate student. I teach mechanics to, say, a postgraduate student. I teach mechanics to PhD student. I can teach mechanics to one of your professors also, right? But the understanding, how much they are going to understand will differ. How much they are going to understand will differ. Why? See, the 12th class student will understand more. Why? Because the inertia is less. As you grow with the age, your inertia increases. You become less and less receptive. A 12th class student is more curious, very much excited about the subjects, very much excited about physics. So he understands more. A graduate student will understand bit less, but still, my experience with the graduate students is good. So they understand more. Even graduate students have got bit less inertia, but still they have inertia, high inertia compared to 12th class student. A postgraduate student, the inertia increases in postgraduate. Postgraduate student, they have lots of inertia. PhD student have got huge inertia. I don't allow PhD student in my classroom. Professors, I can never think of. They have got huge inertia. As the age grows, the inertia grows. You can't teach a person who is of very high age, say 40 years, 50 years. They won't study. They have got huge inertia. They will say, you are teaching me. I am so aged. You are so junior to me. They won't look into what is being taught. They will just say, I am so old. I am so senior to you. So they have got huge inertia. So the change in state will be very small. Change in state is going to be very small. You can never think of teaching the people who are more than 50 years of age. I am not telling for all, but then at least in science. So I really feel sorry if anyone, if you are offended. If you are viewing my lecture and you are 50 years old, I am really very sorry. But still, I am just quoting an example, right? So rate of change has got inverse dependence on inertia. So I can say, I can write here, effect is cause upon inertia. If cause is high, the effect will be high. So I should write here, cause equals to inertia into effect. Effect is the rate of change of state. Inertia is a natural tendency in a system to oppose any change in state, and cause is the external influence to which the system is subjected to. So this is, I think, the Newton's second law, which you apply to mechanics, becomes F equal to mass into acceleration, where m is the measure of translational inertia. In pure rotation, this becomes tau equals to I into alpha, where I is the moment of inertia. I is the moment of inertia. So that's Newton's second law as far as I understand, right, as per my knowledge. So what's Newton's third law? What's Newton's third law? What do you say about third law? It's very simple. Every action has got equal and opposite reaction. Every action has got equal and opposite reaction. An action and reaction acts on different body. Acts on different body, right? If somebody slaps you, what do you say? What do you think? What do you want? If somebody slaps you, give one slap, one tight slap, right? You will also want to give a return slap, right? You will also like to give him one slap. Your heart allows only one, right? You don't think of two even. It's all about, say, even if you don't give a slap, that's a matter of policy. I seriously believe that even if I am a Gandhian, you know Gandhian? Am I right? Gandhian. Gandhi believed in the philosophy of non-violence, right? Even if I am a Gandhian, then also I can say if somebody slaps me, I would like to slap. My heart will say slap him. I won't do that, but that's a matter of policy. But I would like. And physics is confined to that liking only. Physics is confining itself to that liking. Even if you are a Gandhian by thought, even somebody gives you a slap, you would like to give him a slap. You will. You won't, because that's a matter of your policy. It's your policy not to indulge in violence, but you will like. I'm that sure. Because it's third law, it's a law of nature. It's not Newton's laws, it's law of nature. That every action has got equal and opposite reaction. You don't do that because that's a matter of policy. Or you may give two slaps. You really believe in the philosophy of Bhagat Singh. But then again, you don't want two. It's a matter of your policy that if one gives you one slap, you give two slaps. That's a matter of policy. But you like one. The first intuition, the first voice which comes from our heart is give me one slap, right? So you do it or not, that's a matter of policy. But physics is confined to your intuition, what your heart says. Physics is confined till that. Rest of it is practical considerations. If somebody in front of me is very strong and give me one slap, I won't give him a slap. That's because he's very strong. He might give two more slaps. So I won't do that. But then it doesn't mean I don't want to do that. I want to do that. I want to give him one slap, right? So that's what I think the message is clear to you. So every action has got equal and opposite reaction. I hit the wall, wall will hit me. I am not hurt because I hit the wall. Wall hits me and that's why I am hurt, right? I hit the wall, wall will hit me. When I hit the wall, that can be action. Wall hit me, that can be reaction. So you're hurt by the reaction, not by the action. Your action. Wall is hurt by your action, right? So if you have, say, a body falling on the earth, suppose I don't know, like this, earth attract every body with the force mg, right? Earth attract every body with the force mg. This also attract the earth with force mg. Everybody also attract earth with force mg, right? So if this is action, this is reaction. This is action of the earth on mass. This is a reaction of the mass on earth, right? So that's action and reaction. Everybody has got equal and opposite reaction, and these are the three laws which you have, and whole mechanics is based on these three laws, right? Whole mechanics is based on these three laws. We'll be applying these laws and we'll be doing the problems. We'll be studying this whole mechanics by these laws. So I hope you must have got something out of this.